I'm Dr. B. Srividya, Professor, Department of Chemistry. The topic what I'm going to present is structural information by linear format and Smiley notation. Linear format. What is the need for linear presentation is the chemical structures are traditionally shown as two-dimensional or three-dimensional diagrams, which are very difficult to be stored, searched, and processed by computers. These linear formats usually convert the molecular structures into text strings. When it is converted into text strings, they will be suitable for digital storage, database searching, computational analysis, data exchange between software tools. A linear format usually represents a chemical structure in a form of sequence of characters. These sequence of characters can be letters, it can be numbers and symbols. These linear formats include encodes, atoms, bonds, connectivity, branching, and ring formation. The general features of the linear formats includes every atom in the linear format is written in a specific order. The bonds are usually represented by symbols. The branches in a structure and the rings are encoded using parentheses and numbers. This linear format representation is compact and it can be read by machines. The advantages of linear formats include these are very easy and therefore can be stored in chemical databases. It is highly suitable for computer processing. This linear format enables fast searching and comparison of structures can be easily made. It is highly useful in chem informatics and molecular modeling. These linear formats also include limitations. They do not directly show the 3D geometry. They require software for visualization, might be also sometimes difficult to interpret manually for complex molecules. The next is Smiley's notation, which is nothing but simplified molecular input line entry system. This Smiley's is a widely used linear notation system and it is used for representing chemical structures. It encodes molecular structure using ASCII characters. This Smiley's is commonly used in chemical databases, drug design softwares, and molecular simulations. The basic rules of Smiley's include the first one is the atoms are written using their atomic symbols. Example, for carbon it is C, oxygen it is O, and for nitrogen it is N. The single bonds are usually implied. Example, for ethane CC. Double bonds are usually represented as double. Example, ethene it is C double bond C. Triple bonds are usually shown by ash symbol, ethine C ash symbol C. Representation of a branching can be done also in Smiley's notation. The branches are enclosed in parentheses. For example, isopropanol, it is represented as CC carbon within parenthesis oxygen. This indicates a side chain is attached to the main chain. It can be used for the representation of the rings. The rings are usually indicated by numbers. The same number shows the start of the structure and end of a ring. Example, you can take cyclohexane. It is C1 start C1, and this can also be used to represent the aromatic compounds, which is nothing but in the cyclic form. These aromatic atoms are usually written in lower case letters, small letters. Example, benzene. All carbons are in small letters C1, CC, CC, C1. Charged atoms and ions can also be represented. The charges are usually indicated by plus sign or minus sign. Example for this is ammonium ion. It is NH4 plus within brackets. The Smiles application, it enables computer aided drug design, useful in material science and polymer modeling, supports molecular simulations and property prediction, facilitates data exchange between chemical software tools. It is essential for chem informatics and chemical databases. The difference between linear format and Smiles notation is linear format is a general idea of writing molecules as text. Smiles is a specific. It is accepted internationally of the version of the linear format. Smiles provide clear rules for bonds, how to write the branches, rings, and aromaticity. Smiles is a more suitable for engineering applications involving computations. Thank you.